In this video, I'd like to walk you through some examples of operations on matrices. Here are the examples that we'll be working through. We'll be showing the multiplication of matrices and use that multiplication to verify the associative property. And then we will use addition of matrices to demonstrate the commutative property of addition for matrices. And then next we'll do some addition, subtraction, and even finding the inverses of some matrices. Oh, let me remind you, by the way, if you're doing this worksheet for the Math 177 assignment, then take note of this information. You'll want to be sure you're writing out your work neatly on a separate line paper, because you'll need to scan and then submit your written work on Canvas. I apologize for that update, that we're now using Canvas and not Blackboard. So let's get started with this first example. The associative property would demonstrate that we can change the grouping of the matrices and that this multiplication still comes out the same, because of course you remember that the order of operations dictates that we would do whatever's in the parentheses first. So that would mean that we would need to do the A times B first, and then we'll take that result and multiply it by C. What we want to do is then do the B times C and see what happens if we multiply A times that B times C. Now be very careful to note that we're talking about the associative property, not necessarily the commutative property, which would say that you can change the order of multiplication for matrices and get the same result. So here, as we do this first one, we're going to take this A times B. So A times B, and multiply that times C. Let's try that. If I multiply A times B, and let me erase the highlights here and show you really thoroughly what we're doing when we're multiplying A times B. What you might think of, if this is your first experience with multiplication of matrices, if we multiply matrix A times matrix B, we're going to take these two matrices and we're going to get a new matrix, right? So when you look at this first element, let's just call this, just not to not to confuse us with anything else. Let's make this a triangle. This element will be the circle. This element will be a square. And this last element will just be a line. Okay, to get that triangle, I hope that doesn't confuse you, but I don't want to use letters or numbers or anything else that could get mixed up with the problem to demonstrate this. To get this triangle, the element is in, notice that it's in row 1 and it's in column 1, right? The square is in row 2, column 1. The circle is in row 1, column 2, and that line was in row 2, column 2. So to get this element, this row 1, column 1, what I'm going to do is I'm going to use from the first matrix, I'll use row 1. From the second matrix, I'll use column 1. And that's how I'm going to get the new element 1, 1, the new element triangle. Let me show you what that would look like. We'd have 1 times 2 is 2, plus 2 times 3 is 6, just to be super clear on where we're getting each of these. Here's the 1, and this 2. So the row 1 is the pink 1 and the blue 2. And then what I'm multiplying by is that purple 2 and this orange 3. Do you see that? That's how we get the new element, by multiplying row 1, column 1. The first element is a 1 times 2. I always question myself whether, when I'm demonstrating this process, whether it'd be easier to just do it or to break it down in each step. So the next example I'll just work right through the problem. I won't stop in between each step like this. But for this first one, I want to be very clear where each piece comes from. So pink 1 times purple 2 is 2. Blue 2 times orange 3 is 6. And when I add those together, I get 8. So this triangle element is going to be 8. So my result of A times B, that first element is going to be an 8. Let's try the next one. Let's stay with row 1, and we'll do column 2. So row 1 and column 2. So to get row 1, column 2, I'm going to multiply the 1 and the 1, and then the 2 and the 0. So I'd get a 1 plus 0, or 1. So it looks like our row 1, column 2 element is going to be a 1. Then let's move to row 2. So row 2, column 1, row 2, column 1, 4 times 2 plus 0 times 3 gives us 8 plus 0, or 8. So we have another 8. And then the last one, we've got row 2, column 1, row 2, column 1, 4 times 1 plus 0 times 0 is going to give us 4 plus 0, or 4. So it looks like our multiplication yields this new matrix 8, 1, 8, 4. I'm going to erase some of this work here because the next step is going to be to now multiply our AB, and our AB again came out to 8, 1, 8, 4. We're going to multiply this times C, 4, 2, 3, 1. To do that multiplication, I'm going to take the 8 and the 1 and multiply them by 4 and 3 and get the new element. So 8 times 4 plus 1, where was it? We were in column 1 still, 1 times 3, which would yield 32 plus 3. And then row 1 from AB, times column 2 from C would yield, I've run out of space here, so let me do this. I'm going to erase this part here. So we'd have 8 times 2 is 16. 1 times 1 is 1. So that's row 1 from AB. Column 2, that was column 2 from C. And that gave us a 16 plus 1, or 17. And down here in this was row 2, column 1. So from the first matrix, I use row 2. 8 times 4, 4 times 3, and then row 2, column 2, so 8 times 2 and 4 times 1. So that's going to yield a 32 plus 3, a 16 plus 1, 32 plus 12, 16 plus 4, or in other words, a 37, 44, 17, and 20. And there we go. That's our A times B multiplied by C. So let me write it here. This is a A times B times C. What we want to now do is show that if we, so let me make that really clear here. It's the A times B times C. What we want to show is that if we multiplied the B and the C and then multiply A times that result, that we'd get the same matrix. And let me assure you, I have already worked that out, and it does, in fact, work out. But what you'll need to do is demonstrate that process. So I'm not going to do that part for you right now, but let me make sure that everyone's clear on what it is that you're going to do next. You're going to multiply the B and the C. So here's B and C. Multiply those two, and then take that result and multiply A times that result. What you should find is that you get the same answer. And go ahead and try this for the part B and part C also. This is a lovely example because if you don't get the same result with each of these multiplications, then you're already knowing then that you must have made an error somewhere. So that's what makes this such a good practice. And it's not so much if you really look at the purpose of this example. What's good about this example is that it's walking you through this multiplication, pushing you to practice this multiplication again and again. So don't skip out on those examples. Make sure that you do that multiplication. Whew, that was a lot of work, and we didn't even do all of them, right? It isn't easy, but once you get the hang of that multiplication, it really will start to seem quite easy. So I hope that you'll continue on and don't give up with that. Let's look at this next example. This next example I think you're going to find is much easier. This addition of matrices is much easier because all you do is simply add the two elements. So to get this new element 1, 1, what we're going to do is add 1 plus 4. 1 plus 4 is 5. And then to get this element row 1, column 2, we're going to take the 3 and the 5 and add those. And then we could add 2 to 6 to get 8. Add -3 to 2. -3 plus 2 is -1. And that's our new element here. And that's all there is to it. Let's see what happens if we reversed that. Go ahead and try that. If we reversed that, you'll see that instead of 1 plus 4, we're going to have 4 plus 1, and that is still 5, right? 6 plus 2 is still 8. 5 plus 3, because 5 plus 3 is the same as 3 plus 5, is still 8. And then -1 plus, oh, I'm sorry, I'm using the wrong number. We want this purple 2, right? The 2 plus -3 is still -1. But practice this with each of these 3 examples to prove to yourself that yes, that addition of matrices is in fact commutative. You can change the order in which you add 2 matrices and you get the same result. If you flip to the next page of your handout, or if you flip over to the back, if you copy this on 2 sides, we see a few more examples. Here again, we've got an A plus B, and then so A plus B, 1 plus 2, 2 plus 1, 4 plus 3, and 0 plus 0. That would yield a 3, 7, 3, 0. And then if I did the B minus C, that will yield 2 minus 4, 1 minus 2, 3 minus 3, 0 minus 1, or in other words, -2, -1, 0, -1. And was that all we were? Yeah, that was all we were doing for that example. So there's A plus B and B minus C. Now this finding the inverse, that's what this notation means, the inverse of matrix B. So if B is given as 2, 1, 3, 0, and we want to find its inverse, then what we're doing, let me move this one over here. That's not what I meant to do, sorry. What we want to do is then take this matrix and say, what would I multiply that matrix by to get the multiplicative identity? Now, this is the multiplicative identity for a 2 by 2 matrix. So what I'm doing is I'm looking for these 4 elements, A, B, C, and D, that when I multiply yields the 1, 0, 0, 1. There are a couple ways to solve this. This one works out pretty easily. Let me show you how. If I do the multiplication, then I have 2 times A is 2A plus 1 times C. So C, that has to add up to this 1, right? So the 2, 1 multiplied by AC, 2 times A, 1 times C, gives us this new element 1. And then if I do this 2, 3 with CD, I'm going to get this 0. So 2C plus 2 and 1, A and C. I'm sorry, I'm saying the wrong pieces there. So the row 1, column 1, here's our 2A plus our 2A plus 1C. And then we want the first, we want the second column. Sorry, I hope I didn't confuse you with that. I should just keep these circled to avoid this confusion. The 3 and the 0 multiplied by the A and the C. So that would be 3 times A plus 0 times C. I'm going to keep it easy, simple, by just keeping that 0. Instead of writing 0 times C, we know that's 0, right? And we need this result of 0. Okay, let's move to the next one. When we have, we're back to row 1, right? Row 1, column 2. So 2 times B plus 1 times D gives us this element 0. And then row 2, column 2, 3B plus 0 gives us this element 1. So here's our 4 equations. We have 4 equations and 4 unknowns. So this is a system of equations. Because we have 4 equations, that's going to be sufficient to solve for the 4 unknowns. You could use a matrix to do this. Here's how. What we would do is we'd pull out for the A and the C. So that's these 2 equations. Pull out the coefficients 2, 1, 3, 0, and the result is the 1 and 0. We could use this matrix, get this in reduced row echelon form to solve for A and solve for C. But you know, this one solves a little bit more easily than that. So let's not overlook the simplicity of this particular example. But I wanted to show you this because in your textbook, it does use this matrix to solve for those elements. But this example just presents itself a little bit more easily because if 3 times A plus 0 equals 0, then it follows that 3A is 0 and A is just 0, right? So our matrix that we're looking for, element A, is going to be a 0. And then if I take that 0 up to the 2A plus C equals 1, then I'd have 2 times 0. Where did that 0 come from? It comes from solving for A equal to 0. Plus C is 1. So what that leads us to is that C is going to be 1. So now I have this element also. I could do the same thing over here with the B and the D. Do you see the easiest of the 2 equations to start with? This 3B is equal to 1. So that would lend that B would lead us to B equals 1/3. And then if I substitute that 1/3 in for B, then I would have 2 times 1/3 plus D equals 0. So 2/3 plus D is 0. 2/3 is going to be the opposite of D. So D is negative 2/3 because 2/3 minus 2/3 gives us that 0. So it looks like our matrix, our inverse for B is 0, 1/3, 1, negative 2/3. You could check that result. I have already checked it, so I'm going to say I've checked it. I know that those are correct answers. But you could check this by going back and multiplying this B 2130 times B inverse 0, 1/3, 1, negative 2/3. And check, do I get the multiplicative identity matrix, 1, 0, 0, 1. And if you check that, you'll find that yes, you do in fact get that. Now I know these aren't easy examples. It's not that any one of them is really challenging. It's just that each one of them takes a little bit of work. But process through these, work through the practice, and do these examples so that you are ready to move on to the next step with matrix. Well, that's all we have for this video. Don't forget, again, that when you finish the examples, you'll want to upload your written work onto Canvas. And also there will be some pieces that you'll be asked to type into Blackboard. It's going to be really hard to type those answers into Blackboard until after you've done all the written work. So here's my advice to you is work out each of these examples really neatly, number your problems carefully, and after you have your written work in front of you and you've scanned it and submitted it, then log into Canvas to type in the answers that you're prompted to reply to. Thank you for your work in this handout. Please let me know if you need further explanation.